Hey everyone, and thanks for joining today's webinar. My name is Clayton Dukes, and I'm really excited today to show you how DLT, the premier government solutions aggregator, helps their customers save millions just by using Logzilla Neo as a preprocessor for Splunk. I'm pleased to have Don McLean with DLT from us today. Don is DLT's Chief Cybersecurity Technologist in Washington, D.C. Don, can you fill us in a bit on your experience?
Thanks, Clayton. Yes, I appreciate that introduction. Before I came to DLT, and our job at DLT is to accelerate public sector growth for technology companies, I worked for primarily BAE systems, and in that capacity, I ran cybersecurity programs at a number of different federal agencies. And one agency in particular, I managed some dedicated analysts who did nothing but work with Splunk all day, look worried a lot. And of course, they were human beings, and as human beings, they made mistakes. And I remember one event in particular where a small misconfiguration led to some big problems with Splunk. Splunk at that time ceased to function if you ran over the licensing requirements. I don't believe that's the case anymore. But even before we installed Splunk, we had to worry about how much data could we ingest, which data sources could we afford to be without, which data sources were actually essential, how much would we get, what would we do if we started to get close to our limits, et cetera, et cetera. And during that time, there were a couple of questions that no one ever asked of me or anyone else. One was, gee, we have all this excess storage space. What should we do with it all? The next question that I never heard was, gee, our security analysts seem to be sitting around doing nothing all day. How do we keep them busy? And as a consequence, I realized that data, we kept getting more and more data. Data would grow faster than our headcount. We'd get more and more data, but we wouldn't get more people to handle it. It was clear to me that we needed to find a way to work smarter and not harder. So fast forward to the day when Logzilla came to me at DLT and did their demonstration of their product, and you'll see a demonstration later on today. And the key element here is that it could either save me money by allowing me to buy Splunk at a lower data rate or data limit than had been possible before, or if I'm well able to afford what I have for Splunk, I can incorporate more data sources. Or even if I have all my data, and even if I can afford it, I can at least get things done more quickly than I could before. So I'm going to hand it over to Clayton now, and he's going to run through his explanation of Logzilla and also do a live demo, which I think is one of the more impressive aspects of how Clayton does things. It takes a lot of confidence in one's product to do an actual live demo. So take it away, Clayton.
Thanks, Don. So as you can see on the screen here, a little bit about me. I'm a former Cisco Advanced Services engineer, left there to found this company a while back. But even prior to that, I was working in a data center. So my experience and the reason that we did this was out of a need. It wasn't a, hey, let's go do something that's kind of neat. It was years and years of feedback from customers. It was years of my needing the solution. And speaking at Cisco Live that for 5 years while I was there, that really brought a lot of feedback from customers saying, this is really something that we need. And the really that I'm talking about is the network event orchestration. So what you're going to see today is just one component. The ability to pre-duplicate and forward is just part of the solution. And I always say for us, it's not about the logs or traps or whatever you put in here. It's really about what you do with them. And that's what network event orchestration is, right? So that's why we have Neo. And if you look at the traditional mechanisms for managing, monitoring events, you'll hear a lot of companies talk about, well, we do event monitor or event management, right? And everybody kind of uses that term broadly. But the truth of the matter is most of them are really just monitoring, right? That is, I'm going to show you a screen and it might be pretty and I'll give you some graphs and you can search. Well, great. And the next step, of course, is to actually kind of move that into management. But few products actually do this. And then the other part of this is you can't really manage if you're not real time. And we hear that term, and I've heard it for 20 something years, but people haven't really defined what real time means. Is that 15 minutes or 1 minute or 1 second?
And Clayton, my experience with real-time tools is they tend to be real-time, but they kind of are real slow time quite often. Yeah.
That's actually a good point, Don. Thank you. And you're going to see in the product demo, it's when we say it's real time, it's real time. When the event comes in that second, it's available. It's on the charts. You can kick off automations, do whatever you want with it. And then the last part is the scalability claims. And this is one of the things that really kind of irked me throughout the years, is that products put the burden on you to fix their own scale issues. So do you need 1,000 servers to run that product software? Well, I don't think you should, and I don't think you should have to pay for it either. And then we move into actual event orchestration. And this is the ability to bring everything together from other systems. If an event comes in, is it, let's say I have an interface down. Is it Susie going home for the day, or is it a data center WAN interface? It's the exact same event. So how do we know? And as an engineer, you're going to look these things up. If you get an interface down, you'll ping it, you'll do this, you'll do that, go to that database, who owns it, where's it located? All of those things come into play. The difference being, once you're orchestrating this, you're able to do it within a matter of a second or two versus some poor guy having to spend half an hour, 45 minutes or more just figuring out what's going on before they actually start solving that what's going on part, right? So there's three main components here for Logzilla Neo. One is to listen at scale. And I talked about scale a minute ago, right? If you look at the industry average, they tend to index events around 100 to 300 gigs per day, depending on drive speed. You know, the NVMe arrays will get about 300, 350. In comparison, we're able to peak at around 40 terabytes a day on a single box. So it's a huge, huge difference and a redefinition of what we mean by scale. And this all kinds of feeds into that ability to do the real time and be the heavy lifter in front of Splunk or Elk or QRadar or any of those. The next part is event enrichment. So not only are we forwarding less to Splunk, we're able to enhance that data so that Splunk gets more information. So recall that I said going out and looking up, you know, is who owns a device, where it's located, all that. Why don't we add that metadata to that? So when you forward downstream, now you have a lot more intelligent information within the message to do your job with. And then in our case, finally, we can go ahead and resolve it. So we did a webinar a few weeks ago on it's a really cool webinar, how to catch a thief. And if you get a chance, go check that one out, because it was about really melding physical and digital stuff together, where if a student reported a laptop, this is one of our university customers, where you know, laptop or phone gets stolen, we know the MAC address. So the next time that device comes up on the network, it within a few seconds had already gotten out, gone to Cisco ICE, which is Identity Services Engine, look up the access point tunnel, then go to the wireless LAN controller, get the name, and then go to a database, look up, translate that name into the building, the hallway, and the room that they're sitting in, and then go to another database and look up the detective and his phone number and the case ID and notify the detective. And within a matter of a few seconds, he's got that information. He's walking into the room. Huge difference, as you can tell from log management, log monitoring, or for us, it's whatever you put in here, not just logs, but into the actual orchestration of everything together. So what you're looking at here is another problem, very common in networks, a data storm, right? Somebody misconfigures something, something goes wrong, and you can see this screenshots from an actual customer. There's a couple things blurred out here. But this was their engineering team pushing out changes. And if we look here, in a very short amount of time, they got almost 1 billion events. 93% of those were duplicate events. And down here, you'll see one device every minute, 70,000 events, 90,000, 62,000. That's huge. If your systems aren't built to handle that, it's going to cause big problems, right? So you think about how your current solution handles a data storm, okay? Does it lock you out? Are you over your license limitation? Can't help you? Or does it drop the events? You can't handle the load. You can't build your infrastructure to handle 10 terabytes a day when you only are normally licensed for 1 terabyte a day, right? You're not going to have 15 servers versus 200 servers or whatever it might be. And then, of course, the big problem here is when you need it most, it's not available, right? There's something horrible going on. I need to find out, oh, I can't get to the product that's supposed to tell me. And then this leads us to ask the question, what's the actual cost per gigabyte? So most of the companies out there, they'll charge a license based on the like price per gig. You'll see PPG, right? But here's the thing, you're going to pay for every byte stored. You're going to pay for not just the data stored, but how many people does it take to manage? How many servers, the power, the infrastructure, top of rack switches. You know, if you've got 15 racks versus 1 server, huge cost difference. And so we look at a TCO calculator, right? This is kind of a typical Splunk deployment for 1 terabyte a day. This is a 3-year TCO. And it's using Splunk's list price. So kind of a little play here. Maybe you got a better deal, maybe you didn't. $536 per gig. So the price per gig is $536, right? But we look at the difference here in the actual Splunk cost near the bottom, what it actually costs you over 3 years, and how many servers it takes to do that versus something like Logzilla Neo. And if you look over here at the right, you'll see this true cost per gig. You end up paying about $11,000 per gig. That's a huge difference once you factor in all of the hardware and storage and labor and everything that's associated with it. Now, look at 10 terabytes a day, okay? Now we have 254 servers for that Splunk infrastructure. This is where I was talking about all your top of rack switches, right? You're not getting all those in one box, or in one rack rather. And notice that the true cost per gig is sort of still right around 11,000, but Logzilla Neo's price continues to go down because of that scalability. So how do we benefit from having our Splunk deployment that costs us millions of dollars and making it actually do what we need it to do and do it efficiently and effectively? And that is to use Logzilla Neo and put it in front of it to be that heavy lifter. Take out all the junk that you don't need to send to it and add even more useful information to it at the same time, right? So if you look at the diagram here, you'll see just a simple pre-duplication. Here's how it works, right? So everything's automatically pre-duplicated. You can actually add rules that would even further pre-duplicate things. So let's say if your events have a timestamp in them that you don't really care about, then remove that and it makes it think it's a duplicate event, which it actually is. So we come in the front of it, we do all of our automation, real-time alerts, automatic repair, things like that. And then we can still send it downstream at the same time. Maybe even in the event, you'll say, maybe you have a meta tag that says this was automatically fixed, but your tools downstream can take that information and provide you more knowledge about what just happened. So in doing this, we can reduce up to 90% of the data sent to these log only or SIEM type solutions, log monitoring or log management systems, if you will, right? End result here is you guys win. And that's why this was built. It was built from an engineer's perspective of solving that problem, or really a bunch of problems, but this is one of them, okay? No need to design for worst case scenario. There's less pressure on you. How do you predict what your requirements are going to be tomorrow, next week, and next year? It also allows you to ingest more. We talk to people all the time that don't send all of their data into Splunk because they can't afford to. But this lets you reduce that, and now you can send everything. So we're going to help you lower your Splunk costs, get all that data that's left on the floor, if you will, things that we couldn't afford to put in. There's no increase in licensing. You get to renegotiate your Splunk license. That's always a nice thing to do, right? And then you're going to add on top of that this ability to automate and streamline. Everything is much more efficient. You're adding real-time alerts, real-time data, all of the automation capabilities, things like what I talked about with the university, right?
And Clayton, this is Don. I really wish we could have had something to speed up our response time when I was running cybersecurity programs, because quite often there were policies that required us to respond and remediate within certain timeframes, and there was a lot of white knuckle moments trying to make that happen. So if nothing else, that would be worth the price of admission right there.
Well stated. Yeah. So, I mean, when I was doing this, it was the same thing. It's all back to mean time to restore, right? And if you're looking at how long it's taking somebody, I used to talk about this at Cisco Live. There was an acronym I used called TAGR. It was Trigger, Assess, Gather, and React. And I would just kind of take a straw poll of how long it took somebody from the time the event triggered to the assessment to gathering of information and then finally reacting on it. And of course, that gathering process piece of the pie was huge. That was where the humans were involved, and they had to go figure out what's actually going on. And an hour and a half later, you're now opening a ticket on a circuit that's down or a security incident or something that really should have been solved within a few seconds, because especially in security, you can't afford that time. That's important. And so finally, the last part of this is don't DOS yourself, right? Everybody gets denial of service, but are you going to deny yourself the one product you need access to when things go wrong? And that's really key here. Next question we get, of course, is, boy, this sounds hard. So I'm going to just go ahead and show you how to do it. You can see a screenshot here of Logzilla Neo. And of course, if you're used to Splunk, you're going to see something very different. Remember, this was built for network event orchestration and true management versus just letting you kind of pluck out and search events and carving data out here and there. Right? But we look at this screenshot here, and the live one I'll show you is probably somewhere near this, but 5 million events, 70% of them were duplicates. We look on the Splunk side, and we can see there are 3 million events, right? So we're now, this one's halfway. I think we got the wrong screenshot, but the end result here is your license usage has gone from, what would that be? Maybe 60% of your license being used down to just a few percent. Same for your disk usage, right? So Neo forwarding rule. In our land, we just have a simple JSON text file that you can edit, and all of this is built into the help. So really, it's just copy paste. You'll put your window size, which is 1 minute, who you want to forward to and how you want to forward it. So you can see I've added key value pairs here, and this would be who it's forwarded for and the deduplication count. And on the Splunk side, quite simple. You're going to put a transform in, and the transform says grab the forwarded for, so we know it's that host and not the forwarder, and then use the transform to pluck that out. And I'll show you here in a moment what you also do is you grab the duplicated event count, so that when you're creating top host, top X type charts, you include not just the count of hosts, but the meta tag for how many times that event happened. Very, very easy to do. Key here for everything, by the way, is doing nothing gets you nothing, right? If you don't put this in front and realize the cost savings, well, you won't have the benefit of doing it, right? So implementing Logzilla, by the way, takes a matter of minutes. If your infrastructure set up, let's say downstream or upstream logging, maybe using something like syslog-ng, you just funnel it over to Logzilla, Logzilla forwards to Splunk, and you're up and running. So I'll take a minute here to share. And you can see this system is ingesting events. We've got about an average of 26 events per second. You'll see, as I mentioned before, a lot of different things on here. So we can carve out different portions of events. We can let you indicate these things are not necessarily part of a message, but maybe we add metadata to them from external sources so that you end up getting events like data center where this wouldn't normally be part of an event. We can track locations and descriptions, and is this a WAN interface? If it is, then it's a obviously a data center device, and if not, then it's a branch device, and all those kinds of things. So we can track all of that automatically. You'll see a standard duplex mismatch here where everything after the word meta is, added automatically. Device, how important is it in our network? Where's it located? All of those great things to be able to see. So if we look back on this one, I'm gonna turn on the hose here and let it flow. And you can see right now this system's running at around 70% duplicate events, and you're gonna see this spike up here in just a second, and there it goes. So now all of a sudden we've got this data storm coming in, and it's just spewing a bunch of stuff that we don't need to forward to downstream systems. If you look on the Splunk side, so look at the events here, 3.6 million. Over here, we've got 1 million events. We look at our dashboard, and we can see whenever it finishes building here, we get the same top hosts, and we get the counts, and we get the dedupe count, and we get the total just like we would any other way, only we're extracting the total as part of the host and that dedupe count meta tag that's coming in. And it's really just that easy. So now you've got a much smaller license, much smaller footprint. And when you compare this to ingesting a terabyte or 10 terabytes or 100 terabytes a day, that is literally millions in savings for your company.
And Clayton,
yes, sir.
I wish we could do this with my email inbox, because I get about 1 billion messages a day.
Oh, you are funny. I like that. All right, so we're a little bit over the 20-minute mark. I think that might be a wrap.
Yeah, super. And thanks to both Clayton and Don for this. We've actually had quite a few questions come in. I'm actually looking, and 2 more came in just as I'm talking in the chat. We have about a minute or 2 left, so we'll get through a couple, and then we'll be certain to respond. The first question, Clayton, probably to you. It's from Omar. He asks, you showed a slide with a detailed TCO calculator. Is that something I can use?
Omar, I think it was. Well, it's an internal one. We've thought about publishing it, but the math on it is quite intricate, and it's really more a matter of sidelining one of the UI guys on our team to make him write it. We are absolutely happy to share it. We're very confident in it. It's full of references to where the data came from and everything, a lot of it even from Splunk's website themselves. So if you want to contact one of our team, we'll happily get on a Zoom call with you and run your numbers through it for you.
Super. We have another question, and it's actually come in from quite a few people. It looks like Eric, Chris, and it looks like there's another Chris that asked the same question. So hopefully, Clayton, you can address all in the one. They all ask, Splunk has a dedupe feature, so how is this different?
Ooh, I like that question. Here's the thing. Years ago, many moons ago, I think probably about 20, I worked for a company called Micromuse. They also said that they deduplicate. Micromuse, incidentally, is now owned by IBM. It's part of their Tivoli package, I believe. So they deduplicate, but what they're actually deduping is what you see. So even in Splunk, if you say, show me the deduplicated events, Splunk still has the data stored. It's just showing you a deduplicated view. There's a huge difference in that. In this case, Splunk never gets those duplicate events. They simply get a count of them.